Hello, this is Pino of DFT Games. Thank you for joining me in this very brief session about the Typed Pool Manager Unity asset. Now, this is an asset that has been around for many years on the Unity Asset Store, and the videos that were attached to the asset dated back to 2015, if memory serves, so definitely old. I think that it was definitely about time to create a new video about this asset because really it is worth. It's an asset that we use all the time, and it does its job really well. It's scalable and gives us exactly what we need. Now, I'm not going to explain the concept of pooling objects because I'm assuming everybody knows. I'm just going to skim through real quick. So the idea of pooling objects is to not create and destroy every single time that you need to get an object, a new object, maybe an enemy, a bullet, whatever, and then destroy it, because those operation of creation and destruction cost CPU time, right? It costs garbage that then the engine needs to recollect. So it's really a performance negative impact if we create and destroy objects. So what we do is we pool objects. So let's say I have bullets to fire, I create 10 bullets, I keep them there, and when I need them, I use them, and when they have been used, they go back into the pool. Just as simple as that. Now, one thing that is painful about the usual pool managers that are around is that they just manage game objects, right? But, you know, when I instantiate an enemy, I need an instance of the enemy, yes, but the enemy script that is attached to that game object. Same goes for bullets and whatever. So it's kind of painful to have to retrieve an object from a pool and then have to retrieve also the script, and yeah, it's cumbersome, which is why we created this typed pool object, which allows to retrieve and manage pools of what we need. So let's see this, how it works. Here on the screen we have a very simple demo scene, which is a part of the package, naturally, and three prefabs: a capsule, a cube, and a sphere. Now I have a game manager, and the game manager has these three prefabs, right? Now, for the sake of simplicity, I just hit the play button and see what happens. That is what happens. So I have a continuous instantiation, but it's not really an instantiation, right? I have pools managers that basically create a set of these objects, and they provide these objects to the game manager when the game manager needs it. Now, I used a script that is trying to get as many as possible really fast. If you look at the game screen, it's here. We have a bunch of these objects that basically are positioned on top, they fall, and when they hit the plane, they just go back to the pool. As you can see here on the left, the objects are activated and deactivated as needed, and the pools are automatically increased in space or decreased depending on how fast the objects are necessary to the game manager that is managing it. So that's basically a quick demo of how this works in practice and how the objects are taken from the pool and then released back to the pool. Now, how this works, we can see that if we pick one of these objects, they have a pooled object script attached. Okay, now if I look at the prefab, that script is not there. I only have the release object, which is a script, here we go, that is just doing one thing. It checks the collision. If I'm not colliding with the plane, I do nothing. Otherwise, I retrieve this pulled object and I call dismiss. So basically, this is all you need to do to, instead of destroying an object, to send it back to the pool. The script pulled object is automatically attached to the object by the pool that has produced that object instantiated and kept into the pool of available objects. Okay, so this happens automatically. Let's see how this is implemented. So let's go to the game manager and have a look at the script. So naturally I have the prefabs declared here. Then I create a pool here for the sphere, and these are game objects, regular, just for the sake of looking at how to create a standard pool. But then, let's say that here I want to retrieve not a game object, but a rigid body, right? So the prefabs of the capsule is exactly the same as the spheres and cubes, but in this case it will be treated as a rigid body and seen as a rigid body. So I assume that I want to manipulate this as a rigid body in my game, just hypothetically. Then let's see, let's go to the start. Okay, I have an application frame rate pretty high. Then I initialize the pools. I create a pool of 10 spheres, 10 cubes, and 10 capsules. This is just a one line of code for each pool. Okay, and once I've done this, the pool is available. Now, in the update, what am I doing? I'm doing something pretty crazy, right? I'm counting basically the space between retrieval of objects, 0.01 seconds. So I retrieve an object at random. Could be a sphere, could be a cube, or a capsule. And as you can see here, the capsule is retrieved as a rigid body. And then, okay, I use a single temporary game object to set the coordinates where I want to position this object once has been retrieved from the pool. Okay, so no matter which one it is, if it's the game object or the rigid body, I always have a temporary rigid body to position the object on the screen. And this is pretty much it. So there is nothing else that I do. Right, I call the get element on spheres or on cubes or on the capsule, right? And I get the correct element. If I check here, you see the get elements on capsules gives back a rigid body, while the get element here gets back a game object, and cubes as well gives back a game object. That's what I meant when I said is a typed pool system, which means that if it's a bullet, I'm going to retrieve a bullet. If it's an enemy, I'm going to retrieve an enemy. And that gives me a better and more linear code when I'm actually writing a game. And that is the whole point of the pooling manager. Now, in case you want to put your hands into it, the script is fully commented, so every step is explained. And one important thing that you need to understand is that this system is completely automatic. The optimize method that you can call yourself or let the system call it whenever it's necessary, optimizes the trimming of the pools. So basically, how many objects in average do I want to keep into the pool? And memory is automatically released and object destroyed if the pool is too big, based on the recent activity on that particular pool. Okay, and when the pool has to increase, then that will influence the code, and the system will not trim for a while the list so that it is more efficient in releasing new objects from the pool to the managers. So this is pretty much what the system does. I hope that it's clear enough. In reality, summarizing it, all you need to do is to create the object, creating the pool like this, or a typed pool like this, rigid body or enemy or bullet, whatever you have attached to your game object. Then you initialize in start, and that is pretty much it. Right. One thing, don't forget, in case you want to release the pool, do call the dispose method so that you are guaranteed about the fact that everything in memory has been properly cleaned up. Okay, so when you want to drop a pool manager because you don't need that pool any longer, before you actually destroy the object, remember, call dispose. That is the only important element that you have to remember. Okay, and then remember that in your code, instead of, I don't know, end of life of an enemy, instead of destroying that enemy, what you do is this, right? You dismiss that enemy so that it goes back to the pool, and when it's needed again, you can just get it, like we do here, right? Get element, and that's pretty much it. It's just a few lines of code to implement this. So I hope that this is clear enough in your mind. Don't shy away from contacting us in case you have any questions about this system, or even if you have ideas to improve it, why not? Thank you very much for watching.